This is the activity on properties of a kite and a trapezium. The objective of this activity is to explore and verify the properties of the two shapes, that is the kite and the trapezium, using a geoboard. Then we will try to measure and compare the sides, the diagonals and the angles of these shapes, and conclude what are the similarities and differences in the properties. Let's understand the concept first. So when we talk about a trapezium is a four-sided figure resembling the shape of a boat where one pair of opposite sides is parallel. So in a trapezium, there is only one property. Only one pair of opposite sides will be parallel. Now, very important to note that the trapezium can be drawn in different ways. Like if you draw it upside down, it still remains a trapezium like this, or you can draw one line straight, the other line shorter and the parallel line longer like this. It still remains a trapezium. Unlike a trapezium, a kite has a different shape which resembles something like this. So the two sides, the adjacent sides which I have drawn on top and the two adjacent sides which I have drawn at the bottom, they are of equal length. So one pair of adjacent sides are equal and the other pair of adjacent sides are equal. Likewise, the angles here, this angle and this angle, they are equal. Only one pair of opposite angles will be equal in case of a kite, and the important property is that of the diagonals. So if I draw the two diagonals, they are going to be perpendicular to each other. So when we talk about the adjacent sides, they are equal. Not all adjacent sides, but each pair of adjacent sides are equal. One pair of opposite angles, only one pair, is equal. And then the final property is the diagonals. The diagonals of a kite are perpendicular. Now these are some of the properties of a kite. To perform this activity, we require some material, that is the geoboard, the rubber bands, threads for measuring the sides and the diagonals, then the general aids like ruler, scale, protractor, set squares, notebooks, pencils, etc. Let's perform this activity on a kite and a trapezium now. To perform this activity on the properties of a kite and a trapezium, we have two observation tables on which we will be recording different measurements in case of a kite and measurements in case of a trapezium. Now this is the geoboard which we will be using for making the shape of a kite and a trapezium. This is a wooden board and it has some nails fixed on it in a symmetrical manner. We will be using a simple rubber band for making the shape here using the nails, and we will be using a protractor cum ruler set square to measure the angles, the sides and the diagonals. So first of all, we will start with the kite, the shape of a kite. How do you make a kite using the geoboard and the rubber band? The first thing you need to understand is we need to use any one vertex and go symmetrically across, like the second from here, 1 2, and then go across the other way around. This is 1 2, and then this part of the rubber band has to be stretched more like this, and this forms the shape of a kite. Now if you see carefully, this kite has four sides and we need to first check the length of the sides. So we will be measuring all the four sides using the ruler. So if I measure this side, this is approximately 10.5 centimeters. So all the readings have to be recorded here, 10.5 centimeters. And likewise, this side is around 16 centimeters. So I'll write 16 centimeters. This side is again 10.5 centimeters, and this is 16 centimeters. As you can see here, 16. So 10.5 and 16. Now what do you infer from this? If you see, these two are adjacent sides and both of them measure 10.5 centimeter each. And these two are again adjacent sides and they also measure 16 centimeters each. So the conclusion we can draw is two pairs of adjacent sides are equal. So this is the conclusion drawn in case of a kite regarding the sides. Then come to the angles. So if you see this angle, if I try to measure this angle by placing the protractor like this, I find that this angle is approximately 110 degrees. And if I try to measure the opposite angle here, this is approximately, see, 110 degrees again. So this pair of opposite angles, they measure 110 and 110. So one pair of opposite angles are equal. But what about the other pair? The other pair here comes out to be approximately, this is little more than 90, and this angle is a very small angle, that is a small acute angle less than around 45-50 degree. So that other two angles which we get here, they are not going to be equal. So one pair of opposite angles, only one pair of opposite angles are equal. So we can actually record the other pair also, this angle and this angle also. I am not writing it here, but the students are advised to write the other two angles also, because that will complete all the angles. Then come to the diagonals. If you see, this diagonal measures approximately 14 centimeters and the other diagonal is much more than 14, 20 plus 2, 22. So 14 centimeters and 22 centimeters. So diagonals are unequal, but there is one very important property. If you take one diagonal like this, so you have one diagonal like this and the other diagonal like this, you will find that the angle formed here at the point of intersection, it is exactly 90 degree. You can measure it using the protractor and you will find that the angle is exactly 90 degree. So what do you infer from this? The diagonals are perpendicular to each other. That means they make an angle of 90 degree with each other. Now that is the shape of a kite. So let's remove all these rubber bands and get on to the properties of a trapezium. So if I want to make a trapezium now using this observations sheet, how do I make it using the geoboard? I will have to use one vertex, another vertex. So maybe I can use it like this, and then a vertex like this and another vertex like this. Now this resembles a trapezium. Now if you see the sides of the trapezium, if I try to measure the sides, I will not find any relationship. This is 7.5 centimeters. This is approximately 8 centimeters. This is around 18 centimeters. And the fourth one is around 10 centimeters. So I can't find any relationship between the length of the sides. But definitely this side is parallel to this side and the other pair is not parallel. So one pair is parallel, but there is no relationship among the sides in terms of their lengths. So one pair of opposite sides is parallel. Remember, the lengths of the sides do not have any interrelationship between them. The angles. Now, if you measure all the angles are, this angle is approximately 65 degree. So I can keep on recording the angles like this. This angle is approximately 45 degree. Now this angle is approximately 120 degree, and the fourth angle is approximately 150 degree. So you can measure all the four angles like this. If you have measured all the angles correctly, 65 plus 45 is 110, then this is 120. So 110 and 120 is 230. So the fourth angle should be 360 minus the sum of the other angles. So you can measure it, and this will come out to be approximately 130 degree. So you can conclude that the angles are all different. They may or may not be equal. Even if they are equal, you can't say that it is not a trapezium. If all angles are different, still it can be a trapezium. If two angles are equal or three angles are equal, still it can be a trapezium. But we cannot conclude any property regarding the angles. It is all different, or two same, or three same. Now coming on to the diagonals. Very easily we can conclude from here. This diagonal is around 16 centimeters and this is around 13 centimeters. So if I write 16 centimeters here and 13 centimeters here, the diagonals come out to be unequal. So what is the main property of a trapezium? We can highlight it from this observation table now, that in a trapezium there is only one property that holds good. One pair of opposite sides is parallel. This is the sole property of a trapezium. In case of a kite, adjacent sides are equal, one pair of opposite angles are equal, and the diagonals are perpendicular to each other, but they are unequal in length. And that completes our activity on the properties of a kite and a trapezium.